Hello and welcome. So we are solving linear algebra question from PYQ papers. So far we have solved ECE and 23, 22, 21, and today we are going to solve 2020. And apart from that, we have also solved other branches question from statistics and from mathematics. So you can go through that. You will find a separate playlist where I am solving all the linear algebra question that aligns with the syllabus of data science and artificial intelligence. So you will find the separate playlist for that where we are solving all the linear algebra questions. So today we have only two questions, that is question number 1 and 26. So let's look at those questions. So question number 1. Okay, so question number 1 is here. And what we have been asked that if v1, v2, v3, v4, v5, 6 are 6 vector in R4. So in 4 dimension we have given the 6 vector, right? Which of the following statement is false? We have to find the which of the following statement is false. So if I can put all those my vectors into column of a matrix, let's put those vectors into our column of matrix, and how many components of one column will be? It will have the 4 component, right? Because our vector is in R4, 6 vector in 4 dimensional. So let's not worry about that. So let's put our all 6 vector in a column. V4, V5 and V6, right? So let's check the option. It is not necessary that these vectors span R4. Obviously it is not necessary. Why? Because there might be chance that that we have one vector and that is that is that is that other vectors are the multiple of this v1. So what I can say that all other vectors are depending on this v1. So in that case with these vector I cannot span this 4 dimension, right? Or so it is not necessary that the vector span R4. So this statement is true, but we have to find the false statement, right? These vectors are not linearly independent, obviously, because we have nothing given about this vectors, right? So these vectors are not linearly dependent. How? Let's suppose that uh, that that we have 6 vectors, right? So let's suppose that all the 6 vectors are linearly independent. That means none of the vectors depends on the other vector. So all these are linearly dependent. Then all of these will span more than R4, right? More than R4. So 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 uh, so so if these vectors are from R4, these all 6 vectors are from R4, then there is a case that that we have extra vector, right? So there is chances that these 4 vector will span the R4. Then we have the 2 extra vector, and these 2 extra vector will be some multiple of these columns. That means these 2 extra vector will be depending on some of these columns, right? So these vectors are not linearly independent. So that statement is also correct, because all of these, all six has to be in R4, right? If all of these are, let's suppose, if all of these are linearly independent, then it will span more than R4. But in question what we have given, that in that these are all in R4, so we have something that is more, we have some vector that is more, right? So these two vectors should not contribute to any other dimension, right? So these two vector will be, or any of two vector will be the combination of other four. So that statement is correct, that these vectors are not linearly independent, they are dependent, because all of these six are in from R4, right? And any four of these vectors form a basis in R4. So any four of those will, how we can say randomly, we cannot say this randomly, right? So any four of these vector form a basis is, so this is incorrect statement. If v1, v3, v5, v6 span R4, then it form a basis of R4. So if these are spanning the whole space, the complete space, then these will be the basis for R4. So this statement is correct. So according to question, we have to find the false statement, and this C is the false statement. So C is the correct answer. Now we have question number 26. We consider the following system equation. So we have given linear equations. So we have given this four linear equation. Which of the following condition ensure that the solution exists for the above system? So this one is also a straightforward question. So let's represent this equation in matrix form. Then we can have 1 2 2 4 3 7 3 9, and with that we will have this x1, x2, x3 and x4, and we have in right hand side b1, b2, b3, b4. Now what we can do is we can form a augmented matrix that will be 1 2 2 4 3 7 3 9, and here we will have b1, b2, b3, b4. Now let's apply the elimination. So take this edge pivot and try to eliminate all these. So we will have 1 2 here, and what we are doing is multiplying row 1 by 2 and subtracting it from row 2. So we will have 0, and here also we will have 0, and here we will have b1, here we will have b2 minus 2b1. Then you can do multiply the 3 with column 1 and subtract it from column row 3. It will be 0, 7 minus 6 1, and here we will have b3 minus 3b1. Here we will have 0 and 9 minus 6, that will 3, and b4 minus 3b1. Next we can take this edge pivot and we can eliminate this. So at the end we will have 1 2 b1, 0 0 b2 minus 2b1. Here we will have 0 1 b3 minus 3b1. Here we will have 0 0, and here we will have b4. So b4 minus 3 b1 minus b3, so minus 3 b3 and plus 9 b1. So if we do the calculation here, we will have 6b1, right? 6b1 minus 3b3 and plus b4, right? You see that left hand side 0, then this should be 0 right hand side, right? And similarly in left hand side we have 0, then this right hand side should be also 0. So now what, once you have applied the elimination, and now to find the solution, what you will do, you will do the back substitution, right? So once you will do the back substitution, then you see that this left hand side is complete 0, and to have the solution this left hand side also should be 0. Similarly left hand side is 0, so to have the solution this right hand side should be 0. So what condition we are getting is that b2 minus 2b1 should be 0 to have solution, and 6b1 minus 3b3 plus b4 should be equals to 0. If we have this condition, then we will have the solution. So solution exists for above of system when b2 is equals to 2b1. So b2 is equals to 2b1 and 6b1 minus 3b3 plus b4 equals to 0. So option A is the correct. Okay, so that was easy. So that is all from this video. We have only 2 questions on linear algebra. Next, what paper we will be solving? Next we will solve 2019.